Hey guys, Mrs. Flanagan here. Today we are going to talk about factoring difference of squares. Let's look at this first example. Remember, the first step when factoring is to find the GCF, and the number that can divide 1, this really has a 1 right here, and 16 is 1. So with a GCF of 1, we don't have to factor the GCF out. Then we go straight into identifying our A, our B, and our C. A is the number in front of our x squared term. Remember, if there's not a number written there, that number is really a 1. So A is 1. B is the number in front of our x term. There is no x term, and so B is 0. C is the number without an x, and that is a negative 16. Now we need to find two numbers that multiply to A times C but add to B. A times C, 1 times negative 16 is negative 16, and B is the 0. So two numbers that multiply to negative 16 but add to 0 are 4 and negative 4. And so now we put them inside of our double axe hippobutts. The A in this case is 1. So really I have a 1. My letter is X. So 1x is the double axe part, 1x and 1x, double axe. And then we put the plus 4 in the parentheses, and we put the minus 4 in parentheses. And we don't have to write the 1 at the beginning, and so really it's just x plus 4 and x minus 4 as the answer. Now let's look at this example here. Is there a number that we can divide 9 and 25 by? There's not. And so our GCF is 1, which means we can go straight into identifying our A, our B, and our C. A is 9, B is 0, right? There's no X term, so B is 0. C is negative 25. We want to find two numbers that when multiplied to A times C, they also add to B. 9 times the negative 25 is negative 225, and B is 0. Those two numbers are 15 and negative 15. So now we put those two numbers inside of our double axe hippobutts. The A is 9, so I'm going to replace both of my A's with 9. So it's really 9. My letter is X, so it's 9X and 9X. And then you put the plus 15 in here and the minus 15 in here. But don't forget, we need to simplify, just like how we simplify fractions. So we look at the 9 and the 15. The number that we can divide 9 and 15 by is 3. And so 9x divided by 3 is 3x. And positive 15 divided by 3 is positive 5. And then 9 and 15 can also be divided by 3. And 9x divided by 3 is 3x. And negative 15 divided by 3 is negative 5. And so that is our answer. Now, you may be saying, well, wow, how in the world did you know that it was 15 and negative 15? Because 225 is not on our factor chart. And the numbers could end up being even bigger, into the thousands. And so that's really tricky to find the two numbers that actually multiply to a number in the thousands. And that is where our shortcut comes in. so that we don't have to worry about that. And this shortcut is called difference of squares. It's really important that you know this only works with two terms. So this is one term, that's two terms. And those two terms have to be perfect squares. Perfect squares means that you can square root them nicely. Means when you type the square root into the calculator, it doesn't give you a decimal. And the other thing that has to happen is it only works with subtract. If there's a plus between those two terms, it will not work. That's why it's called difference of squares. Difference meaning subtract. Squares meaning they're perfect squares. You can square root them nicely. And it means that if you have that happen, then you can separate them into these factors. The exact same thing at the very beginning of the parentheses, the exact same thing at the very end of the parentheses, but one's a plus and one's a minus. So now let's use the difference of squares for this problem to make it a little bit simpler. So 9 is a perfect square because the square root of 9 is 3. So you can rewrite this as 3. And then x squared is a perfect square because x is being raised to the power of 2, so that's a perfect square. And this 3x to the power of 2 then is our a. Well, the 3x is our a. And then we have subtract. And 25 is a perfect square because the square root of 25 is 5. So really this is 5 squared. And now the factoring means we have our hippo butts. And the a is basically what is being raised to the power of 2. 3x is being raised to the power of 2. So that goes at the beginning of our parentheses. And then what is being raised to the power of 2 for our second thing? That is a 5. 5 is being raised to the power of 2. And then 1 is a plus and 1 is a minus. Notice that this is the exact same answer as this. So either way is correct. This one is the shortcut way. You can always use this way though if you prefer it. And as far as showing work goes, you don't have to write it like this. What you can do is square root the first term and then realize that the square root of 9 is 3. The square root of x squared is x. That's a review from previous units. So if this is tricky for you, go back and review those previous units. And then the square root of 25 is 5. So it's the 3x and the 5 that we are going to use for the two sets of parentheses, but one is a plus and one is a minus. So that is the only work that you need to show. Make sure though that you are doing the square root after the negative, after the subtract, right? Don't include the subtract in your square root. So do not do this. Do not put the square root before the subtract. Do the square root after the subtract. All right, next example. Remember, the number in front is really a 1. And so we have the square root of 1x squared. That becomes 1x and 1x. And then the square root of 100 is 10. 1 is a plus and 1 is a minus. Next example. The square root of 100 is 10. The square root of x squared is x. So 10x is at the beginning. And then the square root of 1 is 1. 1 is a plus and 1 is a minus. What I want you to do now is examples E and F on your own. Come back to check your answers. Make sure you update your answers if you get them wrong. Go ahead and pause the video now. These are the answers, and something to point out, normally we do put the x first, but the order matters. It's really important that you keep it in the exact same order. Putting the 5x first is not the same answer. Notice how all of these examples look close to being difference of squares, right? They have two terms. They're all being subtracted, but turns out that when you try to take the square root, right, the square root of 3 is not nice. So that means we can't just go straight into the difference of squares. We have to do something first. Remember that the very first step of factoring is you have to check for a GCF first. That is huge. So when you look here, the number that you can divide 3 and 27 by is 3. So we put our GCF in front of parentheses. When we divide out the 3 from the first term, 3x squared divided by 3 is x squared. And when we divide 3 from the second term, negative 27 divided by 3 is negative 9. Now let's do a difference of squares. So we square root the x squared, and the square root of x squared is x. That is going to be at the beginning of our hippobutts of our double set of parentheses. And then the square root of 9 is 3. Remember, 1 is a plus and 1 is a minus, but don't forget the GCF of 3 at the very beginning. So that is our answer. For example H, the number that we can divide 2 and 32 by is 2. So we put 2 in front of parentheses. When we divide by 2 for the first term, we're left with x squared. When we divide by 2 for the second term, we're left with negative 16. Now we can do difference of squares. The square root of x squared is x, so that goes at the beginning of our parentheses, of both sets of parentheses. The square root of 16 is 4, so that goes at the end of our parentheses. 1 is a plus, 1 is a minus. Don't forget the GCF at the very beginning. You have to include that in your answer. All right, I want you to try example I and J on your own. Make sure you come back to check your answer and update your answer if you got them wrong. Go ahead and pause the video now. All right, here's your answer for I, and here's your answer for J. Okay, that is everything that is new for chapter 3. So now let's put it all together. Let's put 3.1, 3.2, 3.3, and 3.4 all together. So these are all review problems. So I want you to try them on your own first, since we've already covered them. You should already know how to do them. And make sure you come back to check your answers. Make sure you update your answers if you get them wrong. Go ahead and pause the video now. All right, for this problem, this is just our difference of squares. The GCF was 1, so we didn't have to factor a GCF out, so that's our answer. Here, this one, the GCF has an x because both terms have an x. So when we divide out our GCF, x squared divided by x is just an x, and negative 2x divided by x is a negative 2. Notice there is no more power of 2, so that means we are done factoring. So that is our answer. For example C, it's 4 terms, 1, 2, 3, 4. So that means it's factor by grouping. Group the first 2 terms together, and our GCF is 2a. They both have the letter A. Here, the green group, the last 2 terms, the GCF is negative 5b. Remember, since it's a negative 5 at the beginning of our group, you have to include the negative for your GCF. And after you divide out the GCFs, 2ax divided by 2a just leaves us with a single x. 6 divided by 2 is 3. The a's are no longer there, so we just have a y. And then here, when we divide out negative 5b, we're just left with an x. And then here, this is a negative 15 divided by negative 5, and so it's a positive 3. Same thing, this was a -5 divided by -5, so it's a +1, but we don't have to write the 1. And these are the same. That is what you want. If they aren't the same, that means you did it wrong. So we take our new GCF and put it out in front. The x plus 3y goes out in front, and 2a is left, and -5b is left. Here, our GCF is 1, so we don't have to factor anything out. Go straight into identifying A, B, and C. Do your number game, your double axe hippo butts, and then the numbers we found were -6 and -2. All right, do examples E, F, G, H, I, J, K, L on your own. Again, this whole entire page is review. It's review of 3.1, 3.2, 3.3, and 3.4. So it'll be good to see what you can remember to do on your own to help prepare you for the test. Don't forget to come back and check your answers. And then if your answers are wrong, make sure you update them. And you can go ahead and pause the video now. Here is the answer for example E. Here is the answer for example F. The most important one with this one is we did have a GCF that was not 1, so we had to divide out that GCF, and we always put that GCF out in front of the parentheses at the very beginning. And the answer for example G is here. The most important thing with this one is remembering that with the double axe part, so the double A's, our A is 6, and so it's 6 double sixes, double A's, and then the letter was X, so we kept it as X. And then this is also huge. You have to simplify, like how we simplify fractions. The number that you can divide 6 and 2 by is 2, so 6 divided by 2 is 3, and -2 divided by 2 is -1. And then the number that you can divide 6 and 3 by is 3. 6 divided by 3 is 2, and +3 divided by 3 is a +1. Here we have 4 terms, and so that's the factor by grouping. This is our answer for example H then. With I, our GCF was a 4x, right? That was big on this one, is noticing that they both had a letter, and so 4x was the GCF, and this is what we have left over. Because there's no more power of 2, we are done factoring. And for example J, it's important to remember that if the x squared is a -1, you have to factor out that -1. So the GCF is a -1. We write the GCF in front of parentheses, and we have to divide out that GCF. So this is what we have left over. And then you just have to remember to break that GCF down at the very beginning. And for K and L, with these ones, both of them, it's important to remember that our A is the double axe part, so the double A part. A is 2 in this case, so I have double 2's. And then the letters W, so you replace the X with W, double W, double W, and then make sure you simplify. So you can divide 2 and 12 by 2, leaving us with 2 divided by 2 is 1. You don't have to write the 1. And -12 divided by 2 is -6. And then 2w plus 1 is already simplified. The only number we can divide 2 and 1 by is 1, so you just leave it. And here our A is 5. So for the double axe part, it's 5, and the R, since we're using the letter R. So 5R is the double axe part. And then again, make sure you simplify, like how you simplify fractions. The only number you can divide 5 and 6 by is 1, so that just stays. And then the only number that you can divide 5 and 10 by is 5. And so 5 divided by 5 is 1. You don't have to write the 1. And -10 divided by 5 is -2.